This is a question for one-way ANOVA. So I have to check the distribution of the following parameters and compare their mean values across the comorbidities category. And comorbidities, remember, in day one, we have made 3 comorbidity categories. Asymptomatic, mild, that was one category. Category 2 was of moderate. And category 3 was of severe. So I'll check these values. So I'll go to this data sheet. And then maybe I'll go to ANOVA and click on this one-way ANOVA. There are many other options, but we are clicking only one-way ANOVA. If you click this, there will be dependent variable and there will be option of grouping variable. So in the dependent variable, what we have to move, there are many. First in the grouping variable. So in the grouping variable, I have to, this one, total number of comorbidity, transform to, I think this is the data. Let me go and check the data, which is the variable here. So I'll go to the data. And because I don't, I think I have forgotten the levels, which I recoded. So you can go.
Ma'am, I think it will be disease severity.
Disease severity, let me check, because there are 2 variables with this name.
Or maybe total number of comorbidities also. We have 3 levels there. No comorbidity.
That's why. More than 2. No, let double check. No, this is the transformed one. What is the variable in this case across the comorbidity categories?
0.
No, in this case, what is that variable? That may happen with you also, because we tend to forget if we don't label it properly. Comorbidity should have 3 categories. I think this data sheet does it have it. SES, smoker, DM. This is
disease severity you have put, ma'am. Asymptomatic, mild, moderate, and severe.
This one. Yes. This one will be the asymptomatic, moderate, and severe. Yes. So disease severity 1 recoded. This will be the group. So, or maybe comorbidities categories, if you want to see, you can have this total number, no comorbidity, 1 to 2 and more than 2. You can take any of these 2. It's up to you, because you are the researcher, so you can take any of these 2. So maybe I'll again go to the analyze, ANOVA, one-way ANOVA. You can have the disease severity recoded, and then you can have this values like SpO2. So SpO2, and I am taking first value now because there are 2 SpO2, maybe SBP, systolic blood pressure, hemoglobin, BMI. So I may take the BMI score. So let's take first 2 or 3, because then the look of the table will be very heavy. So first I'll explain with these 3 variables. Now, before I go to the actual value of ANOVA, first you have to test this QQ plot. You have to do this assumption check. That is there. So you go to this. If you see the homogeneity of variance, you will see here that what is your interpretation of this homogeneity of variance for these 3 variables, whether it is met or not met?
All met.
So all met. So that means we don't have to go for the Welsh. So here it is, don't assume equal Welsh. So I have to assume equal. That is the, this is the Fisher. So it has got a equal variance. So by default, it comes as don't assume, because it is difficult to get this assumption true most of the time when you will actually, because we have modified the data also, when you will be actually doing it, many a time you will find that in case of an independent sample and in case of a ANOVA also, one-way ANOVA, you will not met this variance. Okay, so don't worry for that. You just have to report the Welsh one. So I have clicked this and I have unchecked this. And then you have to have a descriptive table. If you wish, you can have a descriptive plot. And then you have to come this post hoc test. So this, okay, this homogeneity, I did not see that QQ plot, okay. Let me, yes, this was the QQ plot of SpO2 and this was the QQ plot of SBP and for BMI. So it is approximately normally distributed. So we can apply this and then you go to the post hoc test. So there are two options. Can you see here? In SPSS, there are many options. So we get confused whenever we see that. But Jamovi has kept it simple. So in this case, since it is normally distributed and Levine statistics, we are seeing that it is of equal variances. In that case, I will use this Tukey's post hoc. This Tukey's post hoc test, where it will show you the mean difference, report significant, and then maybe flag significant comparison, because then it shows you the star mark. So now if you see, so this is the assumption check. This is the group descriptive, like you can see the value, mean value of SpO2 in asymptomatic or mild, in moderate and in severe with its standard deviation. This also you have to report. And then you can see the value of this F statistics with 2 degrees of freedom. So it comes with 2 degrees of freedom. One is for number of groups and this is for the total sample. And here you can see the value of P. So none of the difference was statistically significant. So then I think if the value is not significant, then you will find that post hoc is also not significant. So you can see here the Tukey's post hoc for SpO2 2. So there it was not significant. Similarly, the post hoc for SBP is also not significant and for BMI is also not significant. So although there was some difference in the mean value here, you can see there was some difference, but ultimately this mean difference was not significant. And this is how you will enter the result. So in this case, like maybe you can have mean and standard deviation of the all three categories. Maybe this is, maybe you can assume it as a asymptomatic and mild, moderate and severe. You can have mean and SD. You can give the value of Levine statistics, F value. You can remove this because ultimately this should not be there. It's a blank template where you will fill the values. F values, because F value will report with the 2 degrees of freedom. So here you write 2 degrees of freedom and then you have to write the pairwise comparison. So you will write the mean difference in this and then maybe the 95% confidence interval of the mean difference. And the interpretation is like in one way ANOVA, it was conducted to determine whether the continuous variable, it was different with the different levels of the independent variable. And the participants were classified into 3 group or more than 3 group. And you have to give the sample size also for group 1, group 2 and group 3. There were outliers or no outliers in the levels, level 1, level 2 and level 3. You have to do it by the box plot. So I assume that you know it. And then this dependent variable, the continuous variable, it was normally distributed. And the homogeneity of variance, the value of P, it was met as assessed by the Levine's test of homogeneity of variance. And then you have to give the mean and standard deviation. So data is presented at mean plus minus standard deviation. And you can write then regarding all these three like DBP, SBP or whatever variable you take. And then if the post hoc is significant, you can write the post hoc. If it is not significant, you can write that the Tukey post hoc was not significant. So this is the way you do the ANOVA. First, you check the assumptions, and if the assumptions, if the homogeneity of variance is met, you click this assume equal, and if this normality is there, then you go for it. Otherwise, if it is not normal, then in ANOVA you will see there is a Kruskal-Wallis. So this is the option which we are not touching. It is again the same. If the data is not normal again, but this is like independent sample t-test. A slight deviation for normality you can apply because this is also a very robust test. So you can go with the ones this one-way ANOVA.
Ma'am.
Yeah.
Ma'am, can you please quickly repeat, ma'am? We are struck actually. I mean, we are stuck with the proceeding.
Okay.
After
Yes.
doing homogeneity and quick plot, what should we do, ma'am?
Okay. So once you have done this, you check with this QQ plot. Let me uncheck this. Okay. Mean difference. This none. And then this descriptive, remove this. This don't. This was like that. Nothing was there. So what we do, like first we see the assumption check, that is the homogeneity and QQ. So if you see the homogeneity, you will see here that the p-value, it is more than 0.05. That means you have to assume this, that the Fishers, we have to see the equal variances assumed. So we have to check this. And then since QQ plot is normal, so you will apply this one-way ANOVA. Otherwise, if this is not normal, then you would have gone here and apply Kruskal-Wallis. But since it is normal, you will apply ANOVA. So for ANOVA, you want descriptive table because you want mean and standard deviation for under each category. You want mean difference also for the post hoc. So post hoc, in case equal variances, can you see here something is written in the bracket, equal variances. So the Levine statistics tells you that it is of equal variances. That's why you click Tukey, you report this flag significant correlation and significance, and then you can see the table. This is the difference. So this is the Tukey's post hoc test. So it tells you the difference, like see the first group, this. So this tells you the mean difference between moderate and asymptomatic and mild. And this tells you the mean difference between severe and asymptomatic. Similarly, the same thing, if you see, this tells you the moderate and severe. That's it, because the severe we have compared it already. So these are the group comparison. But since there is no star mark, that's why it is not significant. Otherwise, here it would have p-value. You can see here they have not given the p-value. But had it been significant, they would have given it the star mark, like, significant or p less than 1 or whatever. So it was not. Similar case is here. And if you come down, this is again, none of the values are significant. And these are the mean difference, means that between these two groups. So group-wise comparison is there. So in general, if the value of ANOVA is not significant, because here you can see that p-value is not significant, then there is no need to do the post hoc. Right? Did you get it, Venkatesh and all other people?
Ma'am, if the p-value is not significant here, then it's we need not do the post hoc, right?
Yes. Okay. Ideally, for you at this level, it is okay. But when you will join in advance, then I may change my statement. So then don't get startled that I have changed my statement. But for basic data analysis, this should be the way, that if the value of p-value of one-way ANOVA is not significant, then there is no need for the post hoc.
Okay, right. Thank you.
Tesh is writing in Tukey's, if it's significant, can we ensure anything from its T statistics? I don't think so, because T statistics is not important here. In this case, it is the F statistics which is important. Okay. They have given the T value, but I have not, I have no exactly, I don't think so T has got any other. Maybe in post hoc, depending on the distribution, you can apply this, but I have not used this. maybe let me check this once. In what case can we apply this?